Geometry, Unit 5, Section 4, the rhombuses, or rhombi. There's two different plural for rhombus. Rhombuses or rhombi, they're both accepted. So, the previous couple of videos, first was on a trapezoid in this unit, which has at least one pair of parallel sides, then a parallelogram, which is a trapezoid with exactly two pairs of opposite sides parallel. And then we got into some special parallelograms. We did the rectangle in the previous lecture. And the rectangle had some special properties of its own. It is a parallelogram, so it has all parallelogram properties such as opposite sides parallel, opposite sides congruent, opposite angles, diagonals bisect, all that good stuff. But it also is not just opposite, it's all angles congruent because it's four right angles, and perpendicular sides and diagonals are congruent. Well, today we're going to talk about the rhombus. And the rhombus is almost like the opposite of a rectangle. Now, it is still a parallelogram, so it still has all the properties of a parallelogram. Opposite sides parallel, opposite sides congruent, diagonals bisect each other, opposite angles, all that stuff. But then it has its own set of properties, much like the rectangle had its own set of properties. And it's really important to remember the difference between these two shapes, the rectangle and the rhombus, because they are opposite in a lot of ways when it comes to their sides and their diagonals. A rectangle had all angles congruent. All four angles were the same because they're all 90. Well, a rhombus doesn't have all angles congruent, but it has all sides congruent. So it's got four congruent sides. Four congruent sides. Sometimes we refer to a rhombus as a diamond. But it's got four congruent sides. So instead of all angles congruent, we get all sides congruent. A rectangle had perpendicular sides, congruent diagonals. A rhombus has congruent sides with perpendicular diagonals. And so that's really the key difference between the two shapes. One has congruent sides, perpendicular diagonals. The other has perpendicular sides, congruent diagonals. So that's what I mean by they're really kind of opposite each other. So really just remember those, that's really important that you remember that a rectangle, congruent diagonals, perpendicular sides. I'm actually going to write that here. Rectangle v rhombus. So congruent diagonals, perpendicular sides. A rhombus has perpendicular diagonals, congruent sides. So you really see the opposite there. There's one other property that's really important about a rhombus is the diagonals bisect the angle. So like this diagonal here, this diagonal AC, it cuts angle A into two congruent angles, and we see the same thing over here. And we know the opposite angles are congruent. So and we also the second diagonal does the same thing, bisects these angles. A rectangle does not do this. You know, if we take a look at the rectangle again, just go back. You know this whole angle is 90 degrees, but this angle is not congruent to this angle. These are not the same. Like one could be, 30 and 60. It depends on the size of the lengths and the widths, but the diagonals do not bisect angles. And the same thing for a parallelogram, that this angle is not being bisected. This could be, 50 and 30, for a total of 80. They're not bisected, and so same thing with rectangle. But this is the first time we're seeing diagonals bisecting the angles. The diagonals still bisect each other. That's not a rhombus property, that's a parallelogram property. So the rectangle does have that, the parallelogram does have that. But these are the special properties of a rhombus. So if we're given a proof where a shape is a rhombus, so we have all sides congruent, diagonals perpendicular, diagonals bisect angles. We have a lot of properties that can be used in a proof setting. So let's look at one of those. ABCD is a rhombus. I want to prove BE is congruent to DE. And we know by now that that's going to be done with CPCTC. And I'm going to prove a couple of triangles. Now, when we have a CPCTE problem, we don't know which triangles we're trying to prove. Sometimes it's obvious, sometimes it's not. In this case, I could prove this triangle congruent to this triangle. They both have sides BE and DE. But I could also prove this triangle congruent to this triangle. They both have sides BE and DE. So you actually don't know, and sometimes as you look further into the givens, you could tell which it is, but actually in this case, you have a choice. And sometimes that's the worst thing in math is to have a choice. But you do. I could prove this triangle congruent to this triangle or this triangle to this triangle um, through the same methods pretty much. So take a look at how I did it. I chose ABE and ADE, so I chose this one and this one, which is fine, but you could do this proof the same way, but with these two triangles. That's not always the case with CBCTC. Sometimes there are only two, but there's no other givens here, so you kind of have to just pick triangles here. So I chose these two. All right, the first thing, if this is a rhombus, then this is congruent to this because all sides of a rhombus are congruent. And I can also say that BAE and DAE, these angles, are congruent because the diagonals of a rhombus bisect its angles. So there you go. That was two different properties used from the rhombus. We did not use diagonals perpendicular here. We did not use opposite angles. We did not use anything with parallel, alternate interior, or any corresponding, or anything like that. So again, this and I say this every video. This is the hard thing about these givens is when I'm given a rhombus, several things could happen. I could get diagonals perpendicular. I could get diagonals bisecting. I could get all sides congruent. I could get opposite angles congruent. I could get an alternate interior from opposite sides parallel. A lot of different options, and you have to really kind of look at your properties one by one and see, would that be useful here? Would it be useful here? And go through them. So that's the challenging part of these givens. Next, we have a reflexive nature here, and then triangles with side angle side, and then our CPCTC. So I think you can do the rest here no problem. And so side angle side congruent to side angle side. The thing to really take away from this 8-minute video is the difference between a rectangle and a rhombus, because we confuse these two properties quite often. You know, I'm never going to use diagonals congruent for a rhombus because the diagonals are not congruent in a rhombus. That's a rectangle property. So really remember these differences right here. And in the next video, when we get to a square, we're going to put all of this together because that's what a square is, adding these two things together, and has all of the properties of a rectangle and a rhombus and a parallelogram and a trapezoid all put in one shape. All right, so we'll talk about that in the next video. See ya.